Okay, guys, so this is the R code for the chi-squared test. We're literally just going to use the same SPSS files that we utilized in the class. So we need the foreign library that allows us to load in SPSS files. And then we're going to start off with the merit pay example. And we're going to read.spss on this file. If you recall, this is just, we had these three kind of categories of pay, and we had a sample, and we wanted to see whether it met these population proportions of 0.1, 0.65, and 0.25. Maybe we're a union, seeing if the company has actually implemented the system that it's saying it's going to be implementing. So we got to play around with this data a little bit. So we start off, we don't need the category number, we just need the list of frequencies. So what we're doing here is T is to transpose. So we're basically turning the second column into a row. We're taking the second column and turning it into a row, and then using as.table to put it into a table. So we can look what we get. And it's basically just three numbers. But we're going to turn the column names to be the categories. And we really don't care there's one row, we don't really care what it names. And then we can run the function chi-squared test, which for a multinomial test, we just pass it in the data, the vector, or a table. In this case, 42, 365, and 193. And our hypothesized proportions, 0.1, 0.65, 0.25. We're not going to do any sort of corrections for this type of test. And we get reject the null hypothesis and a chi-squared value of 13.3, an incredibly low p-value. And this matches what we did in class. Here we go. Yep, so we've got the critical region, rejective 9.21, 19.33, reject H0. So again, that's exactly what we did, just matches our class. Okay, so the next one is the two-way and the brand awareness data. So let me just get this data here, and this is from our Excel spreadsheet. We're going to load it in. And you can see here that it's kind of in columns. So we have the gender, we have the identifier, and we have a frequency for both. Remember in SPSS, we did a weight by frequency. We're going to do it a little bit differently here. What we want to do is we want to pass the contingency table to the chi-squared test, which means we've got to go from this case where we have what we call long format into wide format. What essentially we're going to do, there's a library called the reshape library here, basically has functions from turning from long to wide to wide to long. And we're going to use dcast. And what dcast does is it takes something in long format, i.e. we've got columns for identity and frequency, and we give it this formula. It's just saying we're going to have identify on the rows and sex or gender in the columns. So let's run this here. And let's just load what we get. So we've got identify in the rows and gender in the columns. We're just going to give row names to be the identify. So it's going to be the row names is going to be what is the first columns. And we're going to basically turn it into a table. This is just a bit, what we have to do here is we can't go directly from the data frame to the table. So we take a matrix first. And we don't need, we go columns 2 and 3, we don't need the first column because that's now in the row names. So that's just some messing around. So we've got the row names as no and yes, the column names as male and female, and then we have the contingency table values. And then we can just send this in and do a chi-squared test. We're going to pass brand table, correct equals false. That's just, we're not doing the Yates continuity correction. And there we go. And just to see what we agree with what we did in class. So again, we get the chi-squared of 46.135, reject H0. And again, an incredibly small p-value. Just recall the continuity correction. the fact we're making a continuous approximation to a discrete distribution, this corrects for that. It's particularly useful when we have cells that have, but if we kind of have really not enough data, it's not going to be enough. But if we kind of have borderline kind of large enough data, so we maybe have one or two expected cell counts less than 5, then the continuity correction can help. So the next thing is we had two different effect sizes, the phi and the contingency effect sizes. The phi is just the square root divided by the number of kind of the count of the data. And here we just add the data up, so we do a sum on the table. So that's the phi, 0.392. And then the contingency table is just the chi-squared divided by the chi-squared plus n, 0.365. And again, just to show you that, where were we? The effect sizes. Here we go. We get exactly the same values, 0.392, 0.365. Just a note, for the next one, we're going to do the Titanic example. We're going to use the Kramer's VSA. So we go chi-squared divided by n times the minimum of rho minus 1, the minimum of rho minus 1s times c minus 1. So let's go and do the Titanic example. So we're gonna read in the Titanic. For some reason, it seems to like give us a blank row at the end. So let's just view that. This is our Titanic data as SPSS, but we go right to the end and we have a blank row. Not quite sure what happened there, but we can just get rid of it by saying, we could have just actually done minus 1310, but we're just going from 1 to 1309. And just actually ignore that one for the moment. I played around, we didn't need that. So first we're going to do the table. We're going to create a table of class and whether somebody survived or not. Which shouldn't take that long. My computer's maybe freezing up on me. Here we go. So we have the class in the rows and whether or not they survive in the columns. We just run the chi-squared test with no correction. And obviously, remember, we got this incredibly significant value because there was obviously a difference in the ratios between the three different classes, and we get moderate effect size. Then we did gender versus survival, sex or gender versus survival, and we have an incredibly large effect size for this. Remember, if we look at the contingency table, basically the majority of males do not survive and the majority of females do survive. So there was a big kind of ratio difference there. And then finally, gender versus class. This isn't quite as strong, but let's just have a look at the table. And you can see that there's a lot more. In third class, there's over twice as many males as females, but that ratio is almost 1-to-1 in first class. So basically, a lot of laborers trying to find their way in going to America. And then, so we see, it's still an incredibly significant chi-squared test with a very low value, but on a large sample size, and the Kramer's V is much, much smaller than this. So this is kind of interesting because when we have large sample sizes, our chi-squared p-value is just going to be incredibly, incredibly small. Just shows in conjunction with kind of effect sizes how we can get some idea of the magnitude of the effects that we're going to be doing. Okay, so that was it for chi-squared test.